All right, so our last scenario here becomes a question of, can we actually write an equation based on this information now? So working backwards from our previous example. So we are told that it passes through some point. And call that point C, 6 and negative 60. Now, I like personally, I'm very visual. I think I've said this before. If I haven't, you'll hear me say it lots throughout the rest of the course. I'm a very visual learner, so I like sketching things out. So when I put point C on my graph, I'm just going to do a rough sketch. It's going to not be to scale at all, but just something to look at. So 6 and negative 60. So that's going to be point C. And then I've got my zeros of the function. And do we remember what those mean? Those are referring to my x-intercepts. Okay, so the zeros of my function are negative 4 and positive 2. So here and here. So relative to my point C, they're farther to the left. Okay, so my parabola is going to look something like this. So I've already got a rough idea of what I should be getting. So what are some key characteristics you can tell me about my equation? Well, that big piece is direction of opening, right? And we always said that A tells us direction of opening. So A is going to have to be negative for it to open downward. Also, for us to be getting to negative 60 that quickly, that seems really, really big, like a really big number. So I'm going to say that A is probably also a big number. Okay, so those are my predictions. So when I go to actually do this question, I can kind of think about, does this answer make sense? And then go back and kind of compare to what I originally thought might be. From here, if we know that these are my two factors, that x equals negative 4 and positive 2, then in my equation, when I isolate y equals 0, my factors would have had to have originally been the opposite signs. And we kind of have already seen this a little bit going the other way. We kept switching signs to get our x equals statement. Now we're going to switch signs to put them back in. And so we get this point. Okay, well that's great. That would have worked if we were factoring. Okay, we don't need to keep the 0 there because we're trying to write the equation for the graph, and we need a y in there if we need an equation. We need two variables. Oops, sorry. Y and x need to be present for an equation, okay? So I've got this part, awesome. What am I supposed to do with that c value? Well, that is what's going to plug in so that we can solve for a. So I'm going to put in negative 60 for y. That's the y coordinate. I'm going to leave a here, and then instead of x, I'm going to put in that 6. Oops. Sorry about the fan here, folks, as it's thinking about all this. So I've got negative 60 equals a times 10 times 40, or 4, rather. Getting ahead of myself. So that's 40a equals negative 60, or a equals negative 3 halves. So my final answer is going to be y equals negative 3 halves, x plus 4, x minus 2. Am I done here? Technically, no, because they ask for general form. General form is ax squared plus bx plus c. I need those three distinct terms. And so what I'm going to have to do is I'm going to have to FOIL this out. Okay, so I get negative 3 halves x squared minus, or plus 2x minus 8 inside here. And then I have to distribute my constant out in front. So it's going to be negative 3 halves x squared minus 3x, and then plus 12. ends up being what it calculates out to be. So that would be my final answer, and it's incomplete without that y equals. Okay, so steps to consider. What information can we extract from the question? How does that fit into what we already know about writing an equation of a function? And then how can we put those two pieces together? How can we reconstruct it to be in general form? Making sure that we always triple check that we've solved for A. Okay, so there's lots of practice questions as usual. So go nuts on those and make sure that you are able to understand general form, because we're going to be working a bit with it for our next couple lessons.